Hello everyone, this is Safa. Welcome back to the MATLAB Control Systems series. In today's video, we're going to simulate and analyze the step response of a critically damped second-order system. Okay, let's jump right in. First, I clear the workspace and close all figure. And next, I define the system parameters. K is the gain, omega n is the natural frequency, and zeta is the damping ratio. Okay. Since zeta equal 1, this is a critically damped system. Okay, next here, I define the transfer function in the standard second order form. And here, display the transfer function in the command window. And finally, I plot the step response. Okay, run. Can see command window here. And plot. Okay, the plot show a classic critically damped response. The output rises smoothly from 0 here to 1. There are no oscillation or overshoot. The curve is softer than overdamped system and reaches the final value faster. Compared to underdamped systems, there is no overshoot, but it's still faster than an overdamped response. This behavior perfectly demonstrates what happened in a critically damped second-order system. The fastest response possible without any oscillation. Okay, thanks for watching, and keep watching the next videos where we explore more second-order system behaviors in MATLAB. See you in the next one.